My suggestion is to always approach your integration designs with 3 questions. 1. Is it efficient? 2. Is it resilient? And 3. Is it auditable? Our support teams will often ask for replicable logs when you face an issue. If these logs are implemented at the start, then you can just copy and paste them directly into the thread and move on to solutioning. If you're querying old data for dates that Google will no longer be updating the values for, consider storing it locally in your own proprietary database. Hello and welcome. I'm your host Corey Lucino, and this is Google's Ads DevCast. I'm really thrilled for our topic today because we're going to be talking about something that is critical and that many of you grapple with, maybe without even realizing. This episode is all about managing your integrations at scale. Now, when we say scale, what exactly are we talking about? We're not just talking about building an integration that pushes a few hundred keywords or uploads weekly conversion reports. We're talking about managing thousands, tens of thousands, even millions of operational requests flowing seamlessly through automated pipelines without continuous oversight, without maintenance, without triage. Ideally, these are fully automated systems that require minimal production interaction or debugging by your engineering teams. How do you keep this engine running smoothly when your business grows and the data you're working with grows with it? How do you avoid triggering quota violations or missing silent operational failures? That's what we're diving into today. Before I get started, reminder, please take our survey for this episode. You can find it at goo.goal/ADC-survey-E4. Okay, let's set a few universal best practices for your applications in motion. It doesn't matter whether you're integrating with the Google Ads API, the Display and Video 360 API, Google Analytics API, whatever it may be. There are a few core principles for any reliable integration with our products that I want to go over first. Number 1, understand rate limits. Understand how they fit into your use cases so you don't hit them, and equally as importantly, understand how to work with those limits once you hit them. This will help avoid additional limitations being put in place if you continue to hit them. So first, our suggestion is to be sure you're checking the returned errors. Some error messages you get back will tell you explicitly, retry in X number of seconds, or maybe it'll tell you something specific about why you were unable to perform that action. Let's take an example. If you're getting an error that you've reached an account limit, you can change your tactic. You can do fewer requests for that account in that short time span. You can also run requests to other accounts in parallel so you don't lose time in processing. And maybe even you can increase the number of operations per request to maximize the number of actions you're performing while minimizing the number of API requests. If you're doing one operation per request, but that given request has the option of having more than one operation, then you're missing an opportunity to decrease the number of API requests. That said, when you scale, that means you're going to be hitting limits. It's inevitable. But you can prepare so when you do hit them, you know what to do, and so you hit them as seldom as possible. It's really important to read the limits and quotas documentation for the products you're using and understand where at a per service or per account level those may be impacting your use cases. Also, hitting a quota limit shouldn't be a terminal failure. Handling those retriable errors gracefully is the key to a positive user experience in your products. If you fail out when a call could just be made again 5 seconds later, then you miss on automating manual interaction away. Alternatively, if you try to hit an API with too many retry loops, you're just hammering an endpoint and will likely end up getting the duration of your temporary cooling period increased. Our best practice suggestion for general retriable errors is that you should implement exponential backoff. This is where you're retrying rate-limited responses at increased intervals. If you first attempt and it fails, then you wait 2 seconds. Then you wait 4. Then you wait 8. Eventually, that request should go through. It may even be a good idea to build in some dynamic queuing so your retry requests don't all cluster to be retried at the same time. This pattern alone keeps automated systems from getting into a cascading block cycle. Track your service limits and let the system breathe when it pushes up against volume thresholds. The second core principle is to implement logging and monitoring, ideally starting with the out-of-the-box features that our APIs already make available to you. Depending on the API and the client library or tooling you're using, there is likely some form of built-in enableable logging. Many of these default as writing to local disk, but even that can be a lifesaver. If you run into an issue and need our help, our support teams will often ask for replicable logs when you face an issue. If these logs are implemented at the start, then you can just copy and paste them directly into the thread and move on to solutioning. If not, the error, getting that reproduced again the same way over and over again so you can get those logs, that may be difficult. And you may have to turn on logging after the fact, and it's just going to be hard to get that information to support. Also, again, depending on the API, there's a wealth of information available to you within your associated Google Cloud project. Go to the Google Cloud project where you enabled the API, and let's say, for example, you're looking for information on the versions you're using with Google Ads API. Maybe you have to upgrade to the next version. You can get a list of all calls made by going into the APIs and services section for that given API, the Google Ads API in this case, and you can see those metrics. The third core principle is an optional one, but highly recommended. Use the official client libraries where available for your needs. We still see developers attempting to roll their own wrappers for our APIs, even for languages that we have client library support for. The official client libraries handle low-level communication for you automatically. Take the result set pagination for an example. In a large report, scrolling through chunks of data is tedious, and it's easy to mess up. Our libraries have built-in handling for pagination, so you don't lose rows and you maintain session consistency. They also manage basic authentication handshakes and default timeout handlers right out of the box. There are instances where you may need to roll a solution for yourself, or languages that we don't support. But the suggested best practice is to use what we've already created for you if you can. And the last core principle I'll cover before diving into product specifics is that you should think about when you need to get data from our APIs versus when storing a local copy is better. If you're querying old data for dates that Google will no longer be updating the values for, consider storing it locally in your own proprietary database. This can mean faster local execution for your customers, but it definitely means fewer hits against Google's APIs, especially for data that won't change. While the source of truth is still Google's backend, and for recent data, you'll still want to pull directly from our APIs for an up-to-date snapshot, creating a local cache of your data and performing higher volume reads against that cache can really save on quota usage and sometimes even on performance. With that all out of the way, let's dig into our products individually and speak to some of their offerings that will help you scale. Let's zoom in first on the Google Ads API, where there are a few great features developers need to be utilizing to improve efficiency. The first of which is specific to automated assets for Performance Max and AI Max. These campaign types use AI to assemble ad creative combinations, and automated assets are exactly what they sound like. The platform builds headlines, descriptions, site extensions, and uses text extracted from your landing pages and your brand footprint. When considering scale, if you're creating 1,000 PMax campaigns today, this takes a lot of the effort out of trying to reiterate your brand decisions that you've already made on your own landing pages. That said, scale requires guardrails, and if you want to maintain brand uniformity, you're probably going to want to programmatically apply brand guidelines so that you can enforce core stylistic exclusions and only allow authorized custom automated assets to be generated. This balances the convenience of automated asset composition with the required brand safety and uniformity that you might have. The second feature I want to talk about of the Google Ads API specifically, but I believe this is also available in other APIs, is partial failure. Setting partial failure means that Google will identify operations that failed within a request and return those error messages specifically for those failed operations while still pushing through the operations that did not fail. This means you only need to retry the requests that failed, and it allows you to move forward making progress with the operations that did not fail. The last one for Google Ads API specifically revolves around batching operations. Let's say you want to update thousands of campaigns or ad groups or both. If you make a single API request for every single mutate, you will burn through operations, hit rate limits, you will induce latency. The key to overcoming this is grouping operations, batching multiple operations together into a single mutate request, and then decreasing the network overhead that you would otherwise utilize by making individual calls. making fewer requests containing more operations rather than a whole bunch of tiny single mutate requests or even small batches with just a couple operations in them is a really great way to improve your efficiency. And there's another positive, specific to batch stop service. If you hit a rate limit in the batch operation, it will actually retry a few times on the back end for you. In many cases, this removes the complication of needing to handle that retry logic yourself. Important pro tip: consider the order of operations when batching. When a batch of operations is received on the back end, it will work through your operations in order and internally batch them based on the type. For example, if you have 5 campaign operations followed by 10 add group operations in the same repeated operations field within your mutate call, then the system will perform 2 calls. One campaign service for 5 operations and the next add group service for 10 operations. However, if you were to group them differently, performance could be a lot worse. If you create 2 campaigns and 2 add groups, but you weave them together such that it's campaign, add group, then this will result in 4 total calls on the back end, and the result could be very slow. Moving on to another product, Data Manager API, conversions aren't just digital clicks anymore. Use cases like uploading offline conversion values and audience synchronization, they're essential ingredients to modern programmatic bidding models. Data Manager API serves as the funnel to send these signals back to Google. When you're uploading audience membership and offline conversion events via the Data Manager API, a lot of the same best practices apply. Firstly, batch your ingestion requests. Properly batching hundreds of events inside individual payloads lets you consume less overhead and stay within standard API quotas. But what happens if things go wrong? This is where knowing the anatomy of API errors makes you an exceptional scaling developer. You'll need to determine if the errors are synchronous or asynchronous. When you submit data via the Data Manager, any synchronous errors are returned instantly as part of the HTTP response payload. These are immediate issues like poorly formatted JSON or missing required fields. It's critical to know that Data Manager API does not support partial failure for synchronous errors. If you drop 1,000 objects in an array and object number 3 in that array has a structural syntax error, the entire request is going to be rejected. All 1,000 objects in this case would need to be resubmitted after fixing. On the other hand, asynchronous errors are discovered after the initial ingestion finishes and the internal systems have processed the individual offline events. Now let's transition to a lighter weight offering where you don't need a full custom API integration. For those who don't know, Google Ads Scripts lets you run JavaScript code straight from the Ads UI to apply automations. Want to make scripts changes at scale? Use bulk uploads. Rather than iteratively mutating objects inside of a loop, you can generate formatted CSV tables and apply bulk changes by uploading a single CSV through scripts. It's efficient, it's clean, it's easily auditable in the Google Ads UI history, and we provide robust official templates that you can use to kickstart and automate your standard tasks. And for developers managing multiple accounts using Ad Manager scripts, sequential account iteration is the enemy of speed. Instead, use the execute in parallel method. This special best practice in the manager account script architecture launches up to 50 execution threads simultaneously across designated managed accounts. This is a massive concurrency boost, and it has the added benefit of increasing your script execution time to an hour instead of the default 30 minutes. Once all parallel worker threads are done, you can supply a centralized callback function to roll up reports, summarize budgets, or log the remaining alerts. It transforms the n number of tasks that you may have taken from a multi-hour synchronous chug into multi-level concurrent updates. Much cleaner, easier to maintain. Let's walk through a quick script trick when working at scale with thousands of accounts. Use a script to populate a spreadsheet with customer IDs, all the customer IDs within your hierarchy, and then also a status column that keeps track of whether or not that account has yet been processed. Then all your script has to do is pull down the set of IDs, populate that sheet, and then for each ID, it'll go ahead and kick off the task to run whatever report you're running for that CID. Once it kicks off that task, it'll just update the status column saying, I'm running, or I'm done. And also, if you were to run out of time, maybe your hour has run through, the next time that script executes, you can set it to run hourly, you can set it to run at whatever cadence you'd like it to, you can actually have it pick up right where you left off again, because that status persists in the sheet. Okay, shifting gears to another product, Display and Video 360. While you can programmatically build rich display campaigns, native modifications to YouTube line items, ad groups, and embedded targets cannot be done directly through the Display and Video 360 API. This sounds like a scaling roadblock, but there is an effective workaround. You can use structured data files, or SDFs, in the Display and Video 360 user interface to edit resources in bulk. You can download those SDFs using the API and edit them programmatically, and then upload them back into the UI manually. Or, if you don't want to maintain a programmatic solution and scale isn't yet a hurdle for you, then you can download SDFs in the UI, edit them, and again, upload them back to the UI. Sometimes the best architectural answer is just adapting to the tools that are already baked into the web interface. Lastly, let's discuss programmatically accessing Google Analytics data. Advanced advertisers are rarely content just staring at simple line graphs in the analytics dashboard. You want to join your analytics data with first-party data, lifetime value estimates, and transaction details. The BigQuery export feature gives you the full power of BigQuery behind your reporting. Enabling the native daily exports from Google Analytics to Google BigQuery delivers event-level data into accessible SQL data tables. Highly recommend trying it out. That said, leveraging the Google Analytics data API directly may be the best way for you to report on your data, but you should prepare for implementation of quota management if that's the case. Quotas can be tricky, and exhausting limits can lock you out of operational report streams temporarily. The latest feature to work around quota issues with large data retrieval is using long-running asynchronous report tasks in the V1 alpha version of the API. This allows for larger customized report creations. Instead of having the connection stay open while data is filtered dynamically, you start a report task. In the synchronous run report method, you are bound by standard HTTP timeout restrictions. If your query involves billions of custom events and user parameters, the server could terminate the long-hanging request. Report tasks separate the request from the execution. You dispatch the report payload versus report tasks.create, and it goes into the background task queue, and the server will return an immutable task ID. You have a background worker on your end that pulls report tasks.get periodically every 30-60 seconds, maybe longer, until that status returns succeeded. At that point, the dataset is uploaded and you can fetch it and download it in multiple separate reports. Now, before we close out, I want to take a quick look at some of the questions that came in from our developer community recently. These are great, concrete, real-world scenarios that emphasize the exact topics we've touched on today. Question number 1. Do we have to use the official client libraries when working with Google's advertising products? While we do recommend it, the short answer is no. Look at the documentation for the product you're working with just to verify, but there are likely guides on how to interface with the API directly with something like REST. Question number 2. How should we handle errors with the Data Manager API? And is that different than our other products? And this is a really good question. Data Manager API separates errors into 2 categories. 1, errors with your implementation that you should fix immediately, such as missing required fields, plain string values where a hash is expected. These are returned synchronously. Data Manager returns those synchronous errors immediately so you can fix these issues in your implementation, most likely just once and not on a record-by-record basis. If these issues pop up due to changes in your implementation, we want you to know about them immediately so you can address them as soon as possible. Number 2, though, is errors and warnings that Google discovers as it processes your data, such as whether a match was found for the user data of an audience member. These are returned asynchronously. Data Manager API returns these asynchronously because they're issues that Google can only detect while fully processing your data. Be sure to look at the docs for more information on the 2 of these. And that brings us to the end of our operational tour. We've covered batch limits, parallel script executions, synchronous patterns, asynchronous patterns, quotas, cross-product workflows, and a whole lot more. My suggestion is to always approach your integration designs with 3 questions. 1, is it efficient? 2, is it resilient? And 3, is it auditable? I'd love to hear about your scaling and integration success stories. I'd love to hear about your questions. Come chat with me and the team on Discord. Links to everything that we've talked about, including the survey, are going to be in the description below. Please take that survey. Your feedback is really, really important to us. Thank you so much. We'll see you in a couple weeks. Happy building.